Today we are discussing the quadratic formula and the discriminant. Let's start with the quadratic formula. The solutions of ax squared plus bx plus c equals 0, where a is not equal to 0. So in other words, the solutions of a quadratic equation are given by this formula. X equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. I know it looks a little long, a little intimidating, but it really is quite simple to use once you get the hang of it. What we're going to do first is look at an example. We want to solve 6x squared plus 5x minus 4 equals 0 using the quadratic formula. So a is 6, b is 5, and c is negative 4. And what we're going to do is just plug those numbers into the quadratic formula, which I will rewrite here. X equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. So let's plug our numbers in. So we have negative 5 plus or minus square root of 5 squared minus 4 times 6 times negative 4 all over 2 times 6. You're probably asking me, are we going to have to memorize the formula? And yes, you do. But you're going to use it so much that it will be second nature. So let's simplify this. Negative 5 plus or minus, well, 5 squared is 25. Minus, well, let's see. First of all, negative 4 times 6 is negative 24. Negative 24 times negative 4 is positive 96. So we have 25 plus 96 all over 2 times 6, which is 12. Well, let's come up here now. So we have negative 5 plus or minus square root of, well, 25 plus 96 is 121 all over 12. We do know what the square root of 121 is. That is 11. Nice whole number for us. And so now this plus or minus gives us two answers. And as you know, in most cases, we do end up with two answers when we have a quadratic equation. Much of the time we do. So we have x equals plus 11 over 12, and x equals negative, I should say, x equals negative 5 plus 11 over 12, and x equals negative 5 minus 11 over 12. Well, negative 5 plus 11 gives you 6. And 6 over 12, of course, gives you a half. So there's one answer. Negative 5 minus 11 gives you negative 16 over 12, which gives you, if you reduce this, negative 4/3. So here are your two solutions. Okay? Now, if you had to factor, that would be miserable to try to come up with 1/2 and negative 4/3 included in your factors. So this is why the quadratic formula is great, because it will work in solving any quadratic equation. Let's take a look at this one. We have x squared equals x plus 20. Just like with the factoring, you have to have your equation set equal to 0 before this will work. Do keep your first term positive. So I would subtract x and subtract 20 from each side to rewrite this equation. And once you do that, you're going to have x squared minus x minus 20 equals 0. Now we can figure out what a, b, and c are. A is 1, because that's the number in front of your x. B in this case would be negative 1, if you plug those in. And c is negative 20. So now let's just plug those numbers into our quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So we have 1, well, it's negative 1. I'll do out the steps for you. Plus or minus, we have negative 1 squared. Do put your negatives in parentheses when you plug them in. Negative 4 times 1 times negative 20 all over 2 times 1. Negative negative 1 is positive 1, plus or minus. Negative 1 squared. Negative 1 times negative 1 is positive 1. Negative 4 times 1 times negative 20 gives you positive 80, all over 2. Well, if we do this out, let's go on to the next one. If we do this out, we have 1 plus or minus the square root of 81, all over 2. Well, we know what the square root of 81 is. We have 1 plus or minus 9. Square root of 81 is 9 over 2. And now we make this into our two answers, where we have x equals 1 plus 9 over 2. So we have 1 plus 9 over 2, which gives us 10 over 2, which is 5. And then we do our minus. So we have x equals 1 minus 9 over 2. So x equals negative 8 over 2, which gives us negative 4. So there are our two solutions. Okay? And that's all we're going to do on this page. Let's go on to the next page of your outline. The discriminant. The discriminant is the part of the quadratic formula that's under the square root symbol. So b squared minus 4ac. And it's kind of neat. It does give you some neat information. If b squared minus 4ac is greater than 0, that is supposed to be a 0, then the equation has two real solutions. If it turns out what's under the square root equals 0, then the equation has one solution. And if it turns out that what's under the square root is less than 0, then the equation has no real solutions because you cannot take the square root of a negative number. Remember, this part does go under the square root sign. So what we want to do in these problems is find the number of solutions of each equation just using the discriminant. So in this first one, 3x squared minus 2x plus 2 equals 0. A is 3, B is negative 2, and C is positive 2. So let's use b squared minus 4ac for all of this, for all of these. So we're going to have negative 2 squared minus 4 times 3 times 2. Well, negative 2 squared is 4. Negative 4 times 3 is negative 12 times 2 is negative 24. Well, that gives you negative 20. And we said that if it was less than 0, it has no solution, or no real solution. So we're going to say no real solutions. Let's do the next one. A is 2, B is 11, and C is 12. Plug your numbers into b squared minus 4ac. So you're going to have 11 squared minus 4 times 2 times 12. So 11 squared is 121. 4 times 2 times 12 is 96, which gives you 25. Well, we said that if b squared minus 4ac was positive, if it was greater than 0, that's your first one, then you had two real solutions. The last problem here, A is 1, B is 8, and C is 16. So we want to know how many solutions does x squared plus 8x plus 16 have? So plug your numbers into b squared minus 4ac. So you have 8 squared minus 4 times 1 times 16. Well, 8 squared is 64. 4 times 1 times 16 is also 64. 64 minus 64 gives you 0. And going back up to what we wrote at the top here, if b squared minus 4ac equals 0, you have one real solution. So we're going to say this particular equation has one real solution. Okay. Now let's see how we can use the discriminant, how it can actually be useful to us in some manner. Let's say we have this problem. The height h, pull this down, the height h in feet of an object shot straight up with initial velocity v in feet per second is given by this formula. H equals negative 16 t squared plus vt plus c, where c is the initial height of the object above the ground. The ringer on a carnival strength test is 2 feet off the ground and is shot upward with an initial velocity of 30 feet per second. Will it reach the height of 20 feet? Use the discriminant to explain the answer. So let's see what we can plug into that equation. We have h equals negative 16t squared plus vt plus c. Now it tells us that c is the initial height of the object above the ground, so c is going to be 2 feet. V is the initial velocity, so V is 30. And we want to know if h, the height, is going to reach 20. So let's see. Let's plug our numbers in. We have 20 equals negative 16 t squared plus 30t plus 2. Now, as always, we have to set our equation equal to 0 before we can do anything. So we're going to have to subtract 20 from each side. So we end up with 0 equals negative 16t squared plus 30t minus 18. Now let's figure out a, b, and c. A is negative 16, b is 30, c is negative 18. Now we're going to take all of that and plug it into our discriminant. Now, the results of the discriminant are going to tell us whether we have no solutions, one solution, or two possible solutions. So let's go ahead and plug that in. So we have 30 squared minus 4 times negative 16 times negative 18. Well, 30 squared is 900. Negative 4 times negative 16 times negative 18 is negative, so that's why I've got my minus there, negative 1,152. So 900 minus 1,152 gives you negative 252. Going back to what we learned about the discriminant way up here, we said that if the discriminant is less than 0, there is no solution. So since we ended up with a negative answer for the discriminant, we're going to say there's no solution. And since there's no solution, that we know in this particular problem that the height of the ringer will never reach 20 feet. So or I should say the shot. The shot will never reach 20 feet. So you can actually use the discriminant to actually see if some situations are even possible. Is this possible to achieve a particular event that involves a quadratic equation? So I thank you very much for joining me. I'll see you in class.